All right, welcome. Today I'd like to do our final review of our radicals. We're going to add and subtract radicals. And something that I've alluded to before is that addition and subtraction is not closely related to radicals. And what I mean by that is, if you have square root of 3 plus a square root of 2, if you're adding, you cannot add the radicands together. It's not equivalent to what the actual answer is. So you have to look for things, very specific things, when you're adding and subtracting radicals. And essentially what you're doing is you're going to combine like terms. So let's think of number 3 as this way. You got 4 square root 3's plus 2 square root 3's. Well, you add those together, that's how many square root of 3's? 6 of them. So you're going to get 6 square root 3. And we still have to subtract a 6 square root 3. Well, those are exact opposites, aren't they? 6 square root 3 minus 6 square root 3. We get 0 for an answer. Let's go on down the middle here. On number 7, these do not match. We can't add these together. But you quickly realize, well, wait a second. This can be rewritten. This can be simplified. So let's simplify that radical. Perfect square of 9, so we get 3 square root 3. Perfect square of 25, so we get 5 square root 3. Now we notice the square root 3's match, so we're going to combine like terms. We've got them, we add 5 more of them, we have 8 square root 3's. Moving right along, on number 10, our radicals do not match, our radicands do not match. Let's split this up. Now keep in mind that 3 on the outside is going to multiply with the 4 that we take out. That minus 6 is going to multiply with the 2 that comes out. And finally, that 9 is going to multiply with that 5 that comes out. Let's clean this up a little bit. We'll get 12 square root 2 minus 12 square root 2 plus 45 square root 2. Those are going to undo each other. Gone. We're left with 45 square root 2. Let's flip it over. 14, let me think here. Yeah, I think 14 is a little bit interesting. In a way, let's go for 14. They do not match. The radicands do not match. Let's simplify it. The 1/2 is going to multiply with the 2 that comes out. Square root of 9 is 3. Yeah, this one isn't so bad. Half of 2 is 1. You can just write that as square root of 5. Now, class, if you could put a 1 right there if you want. But hopefully you can recognize if you got a square root of 5 plus a 3 square root of 5, how many square root of 5s would that be? Well, that would actually be 4 of them, wouldn't it? So you can put that 1 in there if you'd like. All right, let's go on down the line here. 18. Actually, let's not. It's got another 20 in it, so let's bump over to 17. So 17. We want to get these to match. So we got 4 and 3. Square root of 4 is 2. We'll do 3 times 2, square root of 3. On this other side here, we got a fraction, so we learned yesterday you can split that up, can't you? Well, on this side we'll have a 6 square root 3, but over here, square root of 1 is 1. You could write this as, you could put the 6 up top or just leave it to the side, but you're going to have 1 over square root 3. We need to rationalize our denominator. So we'll have 6 square root 3 plus 6 times square root 3 over 3. Square root of 3 times square root of 3 is square root of 9, which is 3. Now class, something that people don't always get is that the 6 out front is actually 6 over 1. And you're multiplying by the square root of 3 over 3. You can simplify before you multiply. And you're going to get 6 square root 3 plus 2 square root 3, which is 8 square roots of 3. How do you feel about that? Let's move on down. Oh, by the way, I encourage you to try some of these on your own. If you want, you can try out 21. Pause the video, try it out, and see if we match. 21's a little bit different, isn't it? For one, you've got 3 different terms that you're adding, but also you've got some variables in there, and also they're not the same variables, so we may have something to discuss here. Right now, none of the radicals match. 5 square root 3y is simplified. Oh, let me slide that down because the other ones are not simplified, so I need some room to work. 27 is 9 times 3, so we can get that down and simplify it to minus 3 square root 3x. 12 is 4 times 3, so we can make that 2 square root 3y. Now notice, class, these are not all like terms. Also notice that, the radical component partly matches. They're all square roots. They all have a 3 in the radicand, but the y's are the only ones that are like terms. So if we've got 5 square root 3y's plus 2 square root 3y's, that's going to be 7 square root 3y. And this term does not simplify with it, so we just write it out. And that's actually very common with adding and subtracting radicals. If they don't match, you get to leave them alone. And let's see, 24 might be a good one. 12 breaks down. A to the third breaks down. You can think of it as a squared times a, or you can think of it as a times a times a. Either way you do it, you're going to realize an a comes out. So we got 5 coming out, or 5's already out. Times 2 times a square root 3a. Okay, this is kind of interesting. So another way to break up that a to the third is a times a times a. Got a pair of a's. A pair of a's is a perfect square, so we're going to get negative 2a square root 3a. 27 breaks down to 9 and 3, and again with the a to the third. So we're going to have a 3 coming out, and a coming out, and a 3a left over. Notice the variable parts match, and the radicand each has a 3. So we've got 10 of them minus 2 of them plus 3 of them. So we'll get 8 plus 3 is 11a square root 3a. And there you go. So class, we got a quiz coming up tomorrow over these 4 handouts. 4 handouts. I'll let you in on a secret. I'm actually just going to take problems from each handout, make sure I got 10 of them, and then yeah, that'll be our quiz. So good luck tomorrow. Thanks for watching.